Alright, hey guys, welcome back. We are on 1.7. We're still talking about solving one variable equations, except this is part 2. So we're going to go more in depth today. So part 1, recall rewriting fractions. Alright, so we want to convert each term from division to multiplication. So if you look over here, remember that a over b can be rewritten as a times 1 over b. So we're going to take our numerator, pull it out to the side, and put 1 in place of that in our numerator, so 1 over b. Okay, so if you look over here at the examples, we have x over 3, and we can pull this x out and multiply it by 1/3. So 1 over 3 times x, now we're going to have 1/3 x. And we do the exact same thing here. We have negative 3x over 5, and we're going to, since this one has a 3x at the top, all we're going to take out is our x, right? We're just trying to move that variable to the side. So we'll have negative 3 over 5 times x, and we get negative 3 over 5x. Okay, so we're moving the top variable out and multiplying it. And if there's something with the variable, it stays. If there's nothing with the variable, we know there's a 1 there, right? So x over 5, we know that there's a 1 here. So we'll keep our 1 over 5, and we'll pull our x out. So we'll have 1/5 times x. All right, negative 6x over 12. We're going to leave 6 over 12 and pull out our x. Okay, so we'll have negative 6 over 12x. And we can also simplify that further to negative 1/2 x. Okay, same thing with c. We know that there's a 1 here. So we can pull this x out, keep our 1. So we'll have 1 over negative 7x. And we want that negative not in the denominator, so just put it out to the side or put it in the numerator. Negative 1 over 7x. Okay, for d, we've got negative 3x over 18. We'll keep that negative 3 in the top, and we'll move our x out. So we'll have negative 3 over 18x. And we can also simplify that even further. Think about a number that will go into 3 and 18. And we'll get negative 1 over 6x. All right, so now let's talk about identifying solutions of an equation. Example 1. Is x equals 6 a solution for the equation 32 equals 2x plus 12? Well, we can plug 6 in for x. Right? It says x equals 6, and we can see if it works or not. So plug in 6 where you see your x. So we have 2 times 6 plus 12, and we get 24. So 32 does not equal 24, so it is not a solution. Okay, so let's practice a few of those. We've got 4x minus 1 equals 27, and it wants us to test x equals 7. Remember that this is not part of the problem. It is what we are plugging in for x. So we're going to have 4 times negative 7 minus 1, and we'll see if it equals negative 27. 4 times negative 7 is going to give us negative 28. So we've got negative 28 minus 1. And then negative 28 minus 1 is negative 29. Negative 29 does not equal negative 27, so this is not a solution. Okay, same thing for b. 18 minus 2n equals 14, and we're going to use 2 anywhere we see an n. So 18 minus 2 times 2 equals 14. Okay, so negative 2 times 2, we're going to have 18 minus 4 equals 14. And then 18 minus 4 gives us 14. So 14 equals 14, we have a solution. All right, don't let c freak you out because of your fractions. We have 1/4 x minus 8 equals 3 over 2, where x equals 38. Okay, so we are going to have 1/4 times 38, and we can go ahead and put that over 1 without changing its value, minus 8. equals 3 over 2. So we'll go ahead and multiply our fraction out. 1 times 38 gives us 38. And 4 times 1 gives us 4. And then we'll bring everything else down. Alright, so we can simplify 38 over 4. Those are both divisible by 2. So we'll get 19 over 2 minus 8 equals 3 over 2. And we can convert this negative 8 to look like 19 over 2, right? So if we go up here and we're running out of room. So if we have 19 over 2, we're going to subtract that from 8 over 1. So let's put it over 1. It won't change its value. And then to subtract it, we need common denominators. So we'll have 19 over 2, and we can make 8 over 1 have a denominator of 2 by multiplying by 2, right? So 8 times 2 is going to give us 16, and 1 times 2 gives us 2. And now we can subtract. 19 minus 16 gives us 3 over 2, which does equal 3 over 2, so we have a solution. Alright, now let's look at solving multi-step equations by clearing the fraction. Okay, so each of these equations contains division. To solve, what step should be done first? Okay, so it's not asking us to solve these, it's asking us what step should be done first. So if we have negative 2/5 x equals 7, the first thing that we need to do is get rid of that fraction, right? So we can multiply by 5 or the reciprocal. So the first thing we can do, we can multiply by 5 since that's being divided, or we can multiply by the entire reciprocal, which would be negative 5 over 2. Okay, so that's what we're going to write. Multiply by 5 or the reciprocal, negative 5 over 2. All right, same thing for B. So we have x over 5 minus 2 equals 7. What would our first step be into getting x by itself? Well, if we use SADMAG, remember that's our order of operations backwards, we need to start by getting rid of that 2. So we have to add 2. All right, looking at C, x minus 2 over 5 equals 7. So we want to get rid of that 5 first, so that's being divided. So in order to get rid of that 5, we're going to multiply by 5. Okay, now our next step is to solve those same equations. So we already know our first step. We're going to multiply by 5. You could also multiply by the reciprocal. I'm just choosing to multiply by 5. So we're left with negative 2x. 7 times 5 gives us 35. Okay, and then our next step into getting x by itself is to get rid of that negative 2. That's being multiplied, so we need to divide it. So we're going to divide by negative 2. We can't do anything else with this fraction, but we're going to move that negative up to the top or out to the side. So negative 35 over 2. Right? For our next one, we said we were going to add 2 first, so let's do that. We'll be left with x over 5 equals 9. And then this x is being divided by 5, so we need to multiply by 5. And we get x equals 45. For C, we said we needed to multiply by 5 first. So we're going to multiply each side by 5. 7 times 5 gives us 35. And then we're going to add 2. Okay, because this 5 is in the denominator and x minus 2 is in the numerator, that's considered a grouping. So we don't want to add that 2 first until we get rid of that 5. So then we're left with x equals 37. Okay, moving on to example 2. We're still going to solve each equation, right? So we have x plus 2 over 5. Just like this, our x plus 2 is a grouping, so we need to get rid of this 5 first. So we're going to multiply each side by 5, and we'll be left with x plus 2. 4 times 5 gives us 20, and now we can subtract that 2. So we're going to have x equals 18. Okay, for b, we've got x minus 10 over negative 8 equals negative 4. Once again, leaving the numerator alone and getting rid of that denominator first. So we're going to multiply by negative 8. And we're left with x minus 10. Negative 4 times negative 8 is going to give us positive 32. And now we can add that 10. So 32 plus 10 is going to give us 42. And we have x equals 42. Last one, 3 plus x over 3 equals negative 5. Once again, getting rid of that denominator. So we're going to multiply by 3. And we're left with 3 plus x. Negative 5 times 3 is going to give us negative 15. And now this 3 is being added and it's positive. So we're going to subtract 3. Negative 15 minus 3 is going to stay negative. We'll have negative 18. All right, moving on to our next page. So we've got solving multi-step equations using the distributive property and combining like terms. Okay, so just a quick little notes box. Equations have two sides and they're separated by an equal sign, right? We know equations have to have that equal sign in order to be an equation. So our left side is equal to the right side. That's why everything we do to one side, we have to do to the other. We want to keep those equal. Equations are solved when the variable is isolated on one side of the equation. So if we have variables on both sides, we need to do combine like terms, move it to the other side, and then we can work on getting the variable by itself so we can solve for it. Okay, for each side, we're going to use the distributive property and combine like terms. And then for both sides, across the equal sign, right? So if we're moving it past our equal sign, we're going to use inverse operations. So don't think if it's on the same side, you are just combining like terms and distributing when necessary. But if you're moving it across the equal sign, that is when you're going to do the inverse operation. So if it's being added, you're going to subtract it. If it's being multiplied, you're going to divide, and then vice versa, right? The correct solution will make the equation true when substituted for the variable. So if we've done it right, the equation should be true. So let's go ahead and look at example 3. We have 6 times 3m plus 5 equals 66. Well, before we can do anything else, we need to distribute the 6 out. And remember, it's going to be 6 times 3m, and it's going to be 6 times 5. So 6 times 3m gives us 18m. 6 times 5 is going to give us 30, and it still equals 66. So now that we have distributed this out, we have an equation that we can solve easily, right? So we're going to start by subtracting 30. Remember, we used SADMEG. So we're going to start by subtracting 30. Okay, so 66 minus 30 gives us 36. This 18 is being multiplied by the m, so we're going to divide it. And 36 divided by 18, we'll have m equals 2. All right, let's look at b. So we have negative 10 equals 5 times 2w minus 4. Once again, before we do anything else, we need to distribute our 5 to the 2w and the negative 4. So 5 times 2w gives us 10w, 5 times negative 4 gives us negative 20. Okay, so now we can solve. We're going to add 20 to both sides. Negative 10 plus 20 gives us positive 10 equals 10w. Now we can divide. So 10 divided by 10, our w is going to equal 1. All right, for C, we have negative 3 equals negative 3 times 2t minus 1. So once again, distribute that negative 3 out, making sure it goes to both terms. So negative 3 times 2t gives us negative 6t. And negative 3 times negative 1 gives us positive 3. Excuse me. All right, now we can solve. We're going to start by subtracting 3. Negative 3 minus 3 gives us negative 6. Now we can divide by negative 6. So negative 6 divided by negative 6, that's still a negative divided by a negative. It's going to equal positive 1. All right, on our next 3 problems, or at least our next 2, we have to distribute on both sides. And on all 3 problems, there's a variable on both sides. Okay, so just remember, if we're moving it across the equal sign, we do the inverse operation, and if we're staying on the same side, we just do it the way it's listed. Okay, so first we need to distribute our 4 to h plus 2. And we need to distribute our 3 to h and negative 2. Okay, so 4 times h is going to be 4h. 4 times 2 is 8. 3 times h gives us 3h. And 3 times negative 2 gives us negative 6. All right, so now notice we have a variable on both sides. So we need to combine our variables. So we're going to subtract 3h from both sides to get all of our h's together. We'll be left with h plus 8 equals negative 6. And now we have this plus 8. We need to subtract it. So negative 6 minus 8, we've got h equals negative 14. All right, let's look at E. Notice on the left side, we're still distributing, but we're using that negative symbol. Remember, that's the same thing as multiplying by negative 1, and that's our multiplication property of negative 1. So it's just going to change the signs of everything inside of it. So negative times 3b becomes negative 3b. Negative times negative 15 becomes positive 15. And now we can distribute our 6 out. So 6 times 2b gives us 12b. And 6 times 5 gives us 30. Okay, we need to combine our b's. And I'm going to do that by moving 12b. So if this is a positive 12b, I'm going to subtract 12b. So negative 3 minus 12 gives us negative 15b. I'm going to go ahead and move our 15. So to get our 15 to the other side, we are going to subtract it. So 30 minus 15 gives us positive 15. And now to get b by itself, we'll divide by negative 15. So positive 15 divided by negative 15, b is going to equal negative 1. All right, let's look at F. Last one. We don't have to distribute anything out on the left side. We do on the right side, but there are still variables on both sides, right? So let's start by distributing our negative 4 to A and to positive 3. Okay, so negative 4 times A is going to be negative 4A, or minus 4A. And negative 4 times positive 3 is going to give us negative 12. Don't forget that this negative is part of this 4 that's being multiplied out. You have to use that. All right, now we've got some like terms on the right side. We have positive 4a and negative 4a. Those are going to cancel out. So we have 18 minus 6a equals negative 12. All right, so now we're just focused on getting this 6a by itself, negative 6a. So we're going to start by getting rid of this 18 by subtracting it. And we're left with negative 6a. Negative 12 minus 18 is going to give us negative 30. And then we can divide by negative 6. So negative 30 divided by negative 6 gives us positive 5. So a equals positive 5. All right, guys, that's it for today's lesson. Go back and work through your practice. And as always, if you have any questions, reach out to your teacher. Have a good day.